Hello everyone, welcome back to my YouTube channel Scribbles in Bioinformatics. In this video, I am going to demonstrate you how to use BFEER for calculation of free energy using the linear interaction energy method. If you have directly landed up here on this video, I would recommend you to watch my previous videos where I demonstrated how to download and install the BFEER software. You might also be interested in watching the video where I demonstrated how to generate MMPBSA data using the BFEER software. In this video, we will focus on free energy estimation using linear interaction energy method. To begin with, for performing linear interaction free energy estimation, you will need two separate simulations. The first system where you have simulated a ligand in complex with protein. We will call this system as the bound state system here on. And the second system that you might need will be the one where you simulated the ligand in its free state, that is without your protein molecule. Later in this video, we will refer this system as free system. So in this example, we will be using the same Mach1 pyrozoline system that I demonstrated in my previous MMPPSA video. The system that I am demonstrating here consists of last 10 frames of my 100 nanosecond simulation. So this is what I was talking about. This is the first system wherein you have simulated your ligand in complex with your protein, and this is the second system where you have only simulated your ligand. Of course, when you simulate, there will be water molecule, but for the sake of clarity and representation, I have removed the water content. So you can check the paper that we have recently published in scientific reports from my lab for more details of this system. Okay, so now let us start with the main agenda of this video as to how do we calculate the binding free energy using the linear interaction energy method. So once you have loaded the PDB and PSF file of your PDB PSF as well as DCD file of your system, you can go to this extension analysis, and there would be a link for our software BFEER if you have installed it properly. And as I have mentioned in my previous video, you can either select this LIE or MMPBSA, but it will become only active after you have selected the working directory. Okay, so now in order to select the working directory, here is my working directory with the folder name LIE, and here are all the files that are required. So what you need to do is to copy the path of this directory. Just copy it and go to this browse button and just paste it over here and click this OK button to set the path. Now you can see once you set the path, the calculation type buttons are now enabled. Since we are now interested in calculating free energy using linear interaction energy, we would select this radio button that correspond to LI. Once the radio button is selected, you can clearly see that the new form has appeared over here. So in this new form for linear interaction energy, you are supposed to provide the input files of the bound state and the free state. Let us start populating this form. First, you need to select the topology file of the bound state by using this browse button. Select this ionized bound.psf file. Why? Because we are giving the topology in form of PSF file, and just hit this open button. Similarly, select the corresponding trajectory file In our case, it is the DCD file. You would select the bound state of the DCD file, click open. Over here you need to define in your bound state what is the name of the ligand. How is that your software is going to recognize what is the ligand in your system? So for that you might use any valid VMD selection. Now I know that the name of residue in my system that correspond to ligand is with the keyword lig. So I can simply put VMD selection command like resname lig that would identify ligand in my protein ligand bound system. Next you need to give the frame range. So in this particular simulation, as I have already mentioned, we are distributing only the DCD file that contains last 10 frames. So of these 10 frames, we will calculate linear interaction energy only on say last 5 frames, that would correspond to frame number 6 to frame number 10. Similarly, we will have to do the same for the free state. We would now browse to the PSA file that correspond to the topology of the free state. We would then select the trajectory of our free state simulation by selecting open, and again we have the same residue selection name. In the free state as well, the name of my ligand is lig. So you can use any valid VMD selection over here. So from your system, from your perspective, the name of the ligand might change. So just make sure that you are giving the right name for identification of your ligand over here. So now let us select the frame range. The first frame for LI calculation would be the 6th frame, and the last one would be the 10th frame. Okay, now there is a next section wherein you are supposed to provide the parameter files that you have used in your simulation. So again go to this browse, and this is the proteins parameter file that I have used in my simulation, and this is the parameter file of my ligand. So if there are numerous parameter files, then you can select whatever number of files that are there by using this control button on your keyboard. So after selecting the proper and appropriate parameter files, just hit this open button so that they will be loaded over here. Now you need to specify the name of the log file wherein the results will be saved. Let us save it as li.log. Let us create a file name as li.log, and in this file your results will be saved. Okay, so now once you have populated this form successfully, there is one more thing that I wish to tell you people, is that by using this by using this default, if you you can directly go ahead for running this calculation, but if you directly run this calculation at this stage, what you will be doing is that you would be using the default value of the empirical parameters alpha, beta and gamma. So by default, the software utilizes the LI coefficient of alpha as 0.18, beta as 0.33 and gamma as 0. So these values of empirical parameters to be included in LI model like alpha, beta and gamma can be changed through this advanced option, and in LI coefficient section you can use your own values if you have standardized them. So these default values, as I have already mentioned, that are shown over here, these default values were determined through An extensive calibration against experimental binding free energies, aiming to provide a balance between accuracy and general applicability. You can read this paper published by Almoff et al. In 2007 for more details on as to how the alpha, beta and gamma values are set to default of 0.18, 0.33 and 0. So the thing is that statistically optimizing the Li coefficients, that is the value of alpha, beta and gamma for a new system is very crucial, because the default value are generalized estimate that may not accurately reflect the specific interaction characteristic for all molecular system. So in short, what I want to say is that if you use this default value, uh, this might not give you a very system specific free energy estimation results. So there will be a separate video wherein I will demonstrate as to how do you statistically optimize this alpha, beta and gamma coefficient. So for timing, and for sake of simplicity, let us focus only on the default values. You can also change the path of this NAMD program if you are using higher version of NAMD. Well, say for example, if you have simulated the system using NAMD 3 rather than NAMD 2, you can simply browse this path from over here and use your version of or newer version of NAMD. So this is where you can set the new NAMD version if you have, or you can change the values for linear interaction energy coefficient. So stay tuned to my channel, as I am going to uh, create a new video wherein I will tell you how is that you optimize these values. Okay, for sake of simplicity, let us just go on with the default values of alpha, beta and gamma. So now once you are satisfied that you have populated the form properly, when you hit this run calculation button, you can monitor as to what things are happening in the background through this VMD TK console button. So over here you can see as to what things happen in the background. Okay, now all I need to do to launch the calculation is to hit this run calculation button, and it will take no time, as you know our system was only of 10 frames, and we only computed the free energy for last 5 frames. So after successful calculation, this dialog box will appear that will say calculation completed successfully, and over here you can see the linear interaction energy has been found to be minus 18.38 kilocalorie per mole. So once you have done this thing, a new file will appear with the name li.log. This is the file name that we have selected. You can open this log file. Just this is the final section that you are interested in. That is, here is where the detailed component wise breakdown of your li result. So this is it, guys. This is how you calculate free energy using linear interaction energy method, implementing the BFEER software from my lab. So this is all that I have got for you for time being. Stay tuned to my channel, and I will be soon coming up with the new video wherein I will demonstrate how is that you set up those alpha, beta and gamma values for free energy estimation, so that you can generate free energy estimation data that is quite accurate to your system. Thank you guys for your kind attention.